In this lecture, I am going to discuss the advantage of per unit in three-phase system. When you will represent line or phase voltage of three-phase system in per unit, then what will be the advantage? As you know from the previous study, there are two types of winding connection in three-phase system. One is called star connection, in which similar polarities are connected together. Together. And other three terminal will be free to give energy or to receive energy. So this is the star connection, and these are the phase winding, and voltage across the phase winding will be the phase voltage. So this is the phase voltage. Voltage between line and neutral point will be the phase voltage, and voltage between line to line will be the line voltage. And it is obvious from this figure that line and phase voltage are not equal in case of star connection, but it will be equal to V line equal to root 3 V phase. And the current which is flowing through the line is the line current, and current which is flowing in phase will be the phase current. And you can easily see in this circuit or from the KCL at this point, line and phase voltage will be equal. So these are the relationship between line and phase quantity in the star connection when you will represent the quantity in conventional unit or in volt. Similarly, in delta connection, this is the delta connection where dissimilar polarities of phase windings are connected together. So this is the delta connection, and these are the phase winding, and voltage across the phase winding will be the phase voltage, and voltage between line to line is line voltage. So you can see here line and phase voltage are equal in case of delta connection, but the current which is flowing through the line is the line current, and current which is flowing through the phase will be phase current. And it is obvious from this circuit, this figure, line and phase current will not be equal, but it will be equal to root 3 into I phase. So this is the relation of line and phase quantity in delta connection. And this is true when you will represent the quantity in conventional unit, means when you will represent the voltage in volt and current in ampere. Now, I am going to discuss what will be the advantage when you will consider line and phase quantity in per unit. So, for star connection, as I have discussed in the previous slide, line voltage will be root 3 times of the phase voltage, and line current will be equal to the phase current, but in conventional unit. Now, in the same way, you can represent the base quantity. If line voltage will be equal to root 3 into V phase, then its base value will follow the same relationship. Its base value of line voltage will also be equal to root 3 times of base value of phase current. And similarly, base value of line current will be equal to base value of the phase current. Base value of line voltage will be equal to root 3 times the base value of phase voltage, and base value of line current will be equal to base value of phase current. Follow the same pattern. Now, from the definition of per unit system, when you are going to represent line voltage in per unit, then what will be its value? Its value will be V line actual divided by V line base. It will be V line actual divided by V line base, and V line actual is root 3 times the V phase. Similarly, V line base will be equal to root 3 times the V phase base, and root 3 will cancel each other, and this is the phase voltage, actual phase voltage to base value of phase voltage. So this will be the phase voltage in per unit. So you can see here line voltage in per unit will be equal to phase voltage in per unit. So this is the advantage when you will represent voltage in per unit, then in star connection, V line and V phase, or you can say line voltage or phase voltage will be equal to each other if voltage will be in per unit system. Similarly, you can calculate the per unit value of line current in star connection, and according to the basic concept of per unit system, according to definition of the per unit system, it will be equal to actual value of line current to the base value of line current. And in previous slide, you have seen line and phase current are equal in case of star connection. So its base value will also be same. So in place of I line, you can write I phase, and in place of IB, you can write ILB. This is ILB. You can write IPB. And this ratio is the I phase per unit. So you can see line and phase current will also be equal in per unit system for the star connection. Similarly, in delta connection, what we know from the previous study, its line and phase voltage will be equal, but its line current will be equal to √3 times of phase current, but in conventional unit, in SI unit. So in delta connection, these are the relations. Line voltage will be equal to phase voltage, so its base value will follow the same pattern. Line current will be √3 times of the phase current, so its base value will follow the same pattern. Now, if you will calculate line voltage in per unit, then according to the definition of per unit system, it will be its actual value divided by its base value. This is line base. And according to this relationship, you can write V line equal to V phase and V line base equal to V phase base. So it will be equal to V phase per unit. So again, you can see here in delta connection, line voltage and phase voltage are equal if you will represent the voltage in per unit. Similarly, you can see per unit value of line current. According to definition, it will be actual value divided by base value of the line current. And actual value of line current is √3 times the phase current. So the base value of line current will also be equal to √3 times the base value of phase current, and √3 will cancel each other. Again, you will get actual value of phase current divided by base value of phase current, and this will be the per unit value of phase current. So again, these two will be equal. So in conclusion, you can say, if you will represent voltage and current in per unit, then in both the connection, whether the connection is star or in delta, in both connection, the line quantity and phase quantity for the voltage and current will be equal. So this is the advantage when you will represent voltage or current of three-phase system in per unit. There is no need to consider multiplying factor √3. So this is the advantage when you will represent voltage or current of three-phase system in per unit. Now, when you will calculate complex power, this is the complex power, or you can say total power in three-phase system, apparent power. It is √3 times of line voltage into line current. And this formula is true for both the connection. It is true. It is valid for star as well as for delta. In the same pattern, its base value will be this. Now, if you want to calculate apparent power in per unit system, then according to the concept of per unit system, it will be its actual value and divided by base value. So this is the actual value, VL into IL into √3, and in denominator, this is the base value, and √3 will cancel each other. That is why it is not written here. And V line by V line base will be V line per unit, and I line by I line base will be equal to I line per unit. And already you have derived for star, and for delta connection line and phase quantity are equal. So the term L can be replaced by P, or you can say the term line can be replaced by phase. So you can see from in this slide, when you will represent line and phase current in per unit, then the total power will be simply the multiplication of V and I. And V and I, there is no need to check whether it is line voltage or phase voltage, or line current or phase current, because it is simply product of either line current and line voltage, or it is the product of phase voltage and phase current. So this is the advantage when you will do the analysis of power system in per unit system. So in conclusion, you can say, if you will represent line or phase quantity in per unit in three-phase system, then there is no need to know whether the connection is delta or star. Its line quantity and phase quantity will always be equal. But in per unit system, if you will represent voltage or current in conventional unit, in volt or in ampere, then there is a need to know the nature of the winding, whether it is in star or in delta. In star, V line will be equal to √3 V phase, and in delta, I line will be equal to √3 I phase. But when you will represent the three-phase quantity in per unit, then there is no need to know about the connection. In both the connection, the line quantity and phase quantity will be equal, and complex power will be V into I, or you can say V line into I line, or V phase into I phase. So these are the advantage. That is why we analyze three-phase system in per unit. In next lecture, I will discuss about the reactance diagram.